Okay, today we're going to discuss polynomials, factoring polynomials completely. And how do we do that? So take a look at the example that we have now. Given f of x is equal to x cubed plus 7x squared plus 2x minus 40. We're going to show that x plus 5 is one of its factors and use this to factor out the given polynomial completely. And how to do that? First step, it is given, it is already known, it is known that x plus 5 is a factor. So meaning to say, if x plus 5 is a factor of the given polynomial, which is x cubed plus 7x squared plus 2x minus 40, since it is given that x plus 5 is a factor, when we divide this given polynomial by x plus 5, we are expecting that the remainder will be equal to 0. Okay, this is the remainder equal to 0. Since in the remainder theorem, since using the remainder theorem, we'll be able to find the factor. Or in the remainder theorem, it says that remainder and factor theorem goes hand in hand. If the remainder is 0, then we can conclude that x plus 5, since this is 0, we can conclude that x plus 5 is a factor. There. Okay. Now, since it is a factor, let's check if indeed it is really a factor using direct substitution. Let's see. So first thing to do is to equate that to 0. X plus 5 equals 0. And then transpose using transposition. So when you transpose a positive to the other side of the equation, then it will now be negative. Or simply, we're just going to take the opposite sign of the constant here. Okay, that's negative. So there, after that, we use direct substitution. So now we have f of negative 5 is equal to, all the variable x will be substituted by negative 5. So negative 5 cubed plus 7 times negative 5 square plus 2 times negative 5 minus 40. Okay, then we proceed next. Then this will be if your base, the base is negative 5. If your base is negative and the exponent is an odd number, the result will be negative. So negative. And then 5 times 5 times 5, that's 125. Okay, plus 7 times. So since the base is negative and the exponent is an even number, the result will be positive. So that's positive 25. Then this will now be negative 10. Okay, plus negative 10 or simply minus 10 if you put it that way. Okay, then minus 40. Now, simplify it further. This will be 125 negative. And then this is 7 times 5 is 35. 35, carry 3. So we have there 3. 7 times 2 is 14 plus 3, 7. So that's 175 positive. And then if you combine this one, this is negative 50. And adding like signs. So now, to simplify it further, for me, it's easier to combine the integers. Negative 125 and negative 50 is negative 175. And then plus 175. So from here, we can now conclude, since the answer is 0, we can conclude that indeed it is a factor. So this is our remainder. Our remainder R. Okay. So the remainder is equal to 0. It is a factor. Now, if it is a factor, then it is a solution. So one of the solutions. So we need to find the other solutions or the other factors. Second step that we're going to do now is to use synthetic division. Okay, we have the first factor. We already have the one of its factors, which is x plus 5. All right, so this is one of its factors, and we need to find out the other two factors. So we need to find out the other two factors here. Okay, so this is our first factor, the second missing, the third is missing. Sir, why is it that there are three factors? If you look at the given polynomial, here we have an exponent that is 3. If the exponent is 3, then we are expecting 3 factors, or at least 3 solutions, or at least 3 roots. There. Okay. Now, we will use synthetic division to find out the factor of this polynomial completely. Okay. So we have the first one, which is given, and then the other two will be solved. Okay, now let's use synthetic division. So we have the numerical coefficient of x cubed is 1. The numerical coefficient of 7x squared is 7, which is positive. The numerical coefficient of 2x is 2 positive. And then we have that negative 40. Now, we have to set up in the synthetic division method. So that's negative 5. Okay, I will just move this upward. So bring down 1, then multiply, that's negative 5. Then add 7 plus negative 5 is positive 2. Then multiply 2 times negative 5 is negative 10. Then add 2 plus negative 10 is negative 8. And then you multiply negative 8 and negative 5, that's positive 40. So now we have the same answer. This is our remainder, which is equal to 0. So from there, we can now have our depressed polynomial. We call this one as depressed polynomial. Okay, polynomial. So what is our depressed polynomial? Since our exponent of the given polynomial is cube, and in the depressed polynomial, in our answer here, it will now be 1 less than the exponent of the given. So since it is cube, it will now be here squared. Hey, x squared plus 2x and then minus 8. Now, if you look at this, server is 1. So there is 1 here, but of course in higher mathematics, we no longer indicate that. It is already understood that there is 1 as the numerical coefficient of x squared. Okay, so now we have our first factor a while ago, which is x plus 5. And the second factor that we have is x squared plus 2x minus 8. But if we look at the second, or the depressed polynomial, this depressed polynomial is still factorable. That is still factorable. Okay. Because if you look at negative 8 here, there is a factor of -8, or the constant here, that will give us +2. find it out. So remember, there is 1 here. 1 times negative 8 is negative 8. So 1, the numerical coefficient of x squared. So 1 times negative 8 is negative 8. So here, we're going to look for the factors of negative 8 that will give us positive 2. So negative 8, what are those? So can be negative 8 and 1. But if you add this one, becomes negative 7. Okay, that's negative 7. So also we have, it can be also positive 8 and negative 1. If you multiply 8 times negative 1, it's still negative 8. But if you add this one, this will be positive 7. Okay, another factor of negative 8 can be 4 and negative 2. If you add this will be positive 2. Okay, now we stop since we already have the middle term. The middle term is positive 2. So that's why it's very important that you master your multiplication table, because every time you do factoring, you have to have a good memory of your multiplication table, not just a memory, of course, a good understanding of what are the factors using the multiplication table. So now, the factors of this one will be x plus 4 and x minus 2, which is this. Okay. So now, we already have the complete factors. X plus 5, and then we have x plus 4, then x minus 2. These are the other two factors that we are looking for here. Okay, so that's how we completely factor out a given polynomial. We use the remainder theorem and of course the factor theorem. Okay. Thank you.